Hello and welcome to our webinar today. And today we will be discussing the topic system layout and design with the Fronius Tauro. I'm joined today by my colleague Mohamed Sidat, our technical sales advisor for the Southern African region based in Johannesburg, South Africa. And myself, David Mwangi, the TA technical sales advisor for the Eastern African region. I'm based in Nairobi, Kenya. Our agenda for today, we are going to take you through the introduction of the Tauro inverters. Then you're going to look at the various design topologies when using the Tauro inverters. We look at, after that, design optimization, where we are going to look at the various tools that can be used for designing the Fronius Tauro. And these include the Tauro configurator, the solar configurator, as well as the SOLAR.CREATOR. After that, we will have a few minutes at the end to answer any questions that might be pending. But also, if you have any questions during the course of the webinar, please feel free to post them in the chat area of or the poll area of the webinar. So therefore, to start talking about the Tauro, of course, we have announced the introduction of the new commercial inverter from Fronius. And this inverter is what we are referring to as a product with a hard shell and a smart core. And in the course of this webinar, we are going to see why this is so. So in more specific details, when we are looking for good performance, we are in most cases also going to talk about the requirement for strong devices. And this is what the Fronius Tauro actually represents. So one of the key attributes that we can mention regarding the Fronius Tauro is the reliable product design. And this has been made possible by the use of durable materials as well as electronics for designing this product. And then also in terms of the compactness of the design, of the product design. So we have quite a number of onboard features as well as the power stage design concept. Then if you look at the entirety of the space of the Tauro, we have a bit of space that is left for making it more flexible for you to adapt more features or other components that might be required to facilitate a smooth operation of your installation. So one of them could be, for instance, in a field installation, you might want to integrate a router or a switch for LAN network inside one of the provided compartment within the Tauro. And that also provides the component that has been retrofitted into the Tauro with the same protection as far as IP is concerned as is equipped for the Tauro inverters. Then in terms of the product design, additionally, we cannot talk about how smart it is. So we are using a very unique concept with a double wall system. And this is making the Tauro have very good attributes or performance when it's working in exposed sun heat. So going forward, let's look at the available Tauro power classes. And we start with what we refer to as the Fronius Tauro standard. And the Fronius Tauro standard is available in the 50 kilowatt power class only, with an operational MPP voltage starting from 400 to 870 volts. This inverter will have up to 3 MPPTs inbuilt, and in terms of current handling capacities for the 3 MPPTs, we can see that we are starting with the MPPT 1 and 2 taking 36 amps each, and MPPT 3 can take a maximum of 72 amperes. The second variant of the Tauro is what we are referring here as the Tauro Eco, and the Tauro Eco is available in the power classes 50 and 100 kilowatts. The MPP operational range for the Tauro Eco will be 580 to 930 volts. In terms of the MPPTs, we have a bit or a big difference here because the Tauro Eco will have only 1 MPPT inbuilt, and therefore this is an inverter that is really optimized for PV, commercial PV installations. The current handling capacity will be, for the 50 kilowatt version, a maximum of 87.5 amps, and for the 100 kilowatt version, 175 amps. Let's now look at the suitability of using the various Tauros in different projects, and what is the suitability criteria for using the Tauro in your installations. So the Tauro inverters would fit best when you have this kind of requirements. It could be a commercial rooftop system. We are talking here about any installation that is above 100 kilowatt peak. Then if you're talking about ease of designing a system up to 5 megawatts, you're going to find the Tauro system be very, very useful for this range of installations. Of course, you can use the Tauro for installations even bigger than 5 megawatts. As you know, with the Fronius Snap inverters, we are now operating in some parts of the world systems even in excess of 50 megawatts in one installation. So the Tauro is not limited to 5 megawatts as mentioned here, but that gives you like ease of design. You are going to find it very, very good when using the Fronius Tauros. Then if you're going to operate or to install the system in very harsh ambient conditions, we are talking also about the possibility whereby you might require to do the inverter installation flat on the ground. So this is possible with the Tauro, and also in instances whereby the Fronius Tauro or the inverter is going to be exposed to direct sunlight. So with the Fronius Snap inverters that are also available for commercial installations, you do know of the requirement that if you're going to have the inverter exposed to maybe more than 4 hours of sun heat per day, we do recommend a bit of a shelter or roof to be built on top of the inverters. So that has nothing to do with ingress protection. It only has to do with the buildup of heat within the inverter, which therefore starts derating after a certain limit of temperature is exceeded. With the Fronius Tauro, this is not going to be a problem because of the double wall concept, and therefore this inverter can operate in direct sunlight or sun heat conditions. Then the other factor that will tell you where to best use the Tauro is when you are thinking about commercial self-consumption systems. So as said already, the Tauro Eco is an inverter in the 50 and 100 kilowatts that has been optimized for large-scale commercial installations, as well as large industrial commercial use. So also we can also talk about applications that are not too ideal for the Tauro inverters. So if you have an inverter or an installation that is going to be less than 100 kilowatt peak, you are probably best still going to find the Snap inverter series, the Big Saimo as well as the Eco to be the best fit for this kind of installations. In terms of the AC cable cross sections, if you're going to be working with this kind of smaller installations, less than 100 kilowatts, then the necessity for using large cross section cables is not there. And therefore, the Tauro inverter is ideal for installations whereby you're going to have large cable cross sections. So the Tauro inverter can take maximum of 240 millimeters square as far as cable connection is concerned. Also, something that might not be too ideal for the Tauro is when you're talking about utility scale kind of installations. So we are talking here the best fit being for large commercial as well as large industrial applications. But for utility scale, probably this might not be ideal. So let's now look at one of the key attributes about the Fronius Tauro inverter that will make it be able to operate even at 50 degrees Celsius at full power. So as you know, with all Fronius inverters, we employ active cooling. So we are not using passive cooling in any Fronius inverter. And therefore that makes the inverter already in terms of performance, way better than any inverter that is doing convection cooling. On top of the active cooling, we also have the double wall system that the Tauro has employed as a design factor. So the entire front cover is comprised of 2 walls. And then this therefore means that because of the active cooling and the double wall concept, you can install this inverter at the direct sunlight. So the active cooling, of course, as you know, is regulated by a fan. And this fan runs at different speeds depending on the heatsink temperature that is detected. So here we look at a comparison between the operation of an inverter that was then done using ISIC sun simulation without the double wall concept, just to show you what a difference the double wall concept makes. So if you're looking at the ambient temperature operating at just around 25 degrees thereabout, if you look at the connection area of the inverter, you are going to see that the temperature there is going to rise all the way up to around 40 degrees Celsius. And this is at an irradiation level of just about 1086 watts per meter squared. But most importantly, the connection area. So the first one was the cover area, and then the connection area, you're going to have an even higher temperature without a double wall. And therefore, if you have an irradiation of about 1086 watts per meter squared, the connection area of the inverter is going to experience temperatures nearly of up to 60 degrees Celsius. So therefore, if you look at the difference between the cover connection area as well as the actual connection area, you're going to see that there's a difference of up to 13.5 degrees Celsius. With the double wall concept, the situation looks a bit different and is actually much better, the performance as far as heat is concerned. So the same simulation was done with the ISIC temperature, and we are also considering the irradiation level of 1086 watts per meter squared. And then if you look at the cover connection area as well as the cable connection area, we can see that the temperature before for the connection area was approaching 60 degrees Celsius. But in this case, we are just below 50 degrees Celsius, which is a very big difference in terms of the performance of the inverter eventually. So inside the inverter with a double wall, you can see that at this irradiation level, we are operating at just about 45 degrees Celsius. But without the inverter, we are approaching, without the double wall concept, we are approaching 50 degrees Celsius within the inverter. So then, because of the heat dissipation from active cooling and the double wall concept, the Fronius Tauro is going to guarantee you maximum service life despite the heat that the inverter is going to be exposed to. So as we have mentioned, the double wall concept, this is the area of the inverter that you're talking about, as you can see in this photo. So we have one front cover, and then behind that, there are some slots for air circulation. And then behind now what is the front cover is another cover that is now covering or enclosing the electronics inside the inverter. And therefore, that is what we are referring to as the double wall concept for the Fronius Tauro. So this concept has not been used for the Fronius Snap inverters or even the Gen 24. Only the Tauro has this kind of concept. So as we can see, because of this direct double wall concept, under direct sunlight, you're going to have at least 13.5 degrees Celsius less inside due to the active cooling and the double wall concept. So therefore, in terms of derating, the Tauro is going to derate at a much later point, as we can see. So also because of the very good temperature control, we all know that the more you expose the electronics inside a component to high temperatures when they are operating, the shorter the lifespan that you can expect out of these components. And therefore, for the Tauro inverter, with these two concepts for active cooling and the double wall concept, you can expect maximum service life of all the components, especially the electronics that are used inside the inverter. So here we can see the circulation when it's sucked in by the circulation fan or the active cooling fan, and how this then heat is dissipated just behind the front cover. And this ensures that the inverter is sufficiently cooled from all corners. Going on forward, let's now look at the recommended installation areas, or what are the installation instructions for the Fronius Tauro. So this inverter can be used for both indoor and outdoor installations. So there is no discrimination whether it's an outdoor or indoor or outdoor installation. And then in terms of the temperature, we are talking about the inverter being able to operate from temperatures starting from minus 40 degrees to 60 degrees Celsius. And then for plus 60 degrees Celsius, this is what will be relevant for the tropical areas, especially in sub-Saharan Africa, whereby in some areas you'd expect very, very high or abnormal ambient temperatures. Permitted humidity will be up to 100%. And then in terms of the installation altitude, you can go up to 4,000 meters without derating the connection or the input voltage on the DC side. Here we have other recommendations as far as installations are concerned. So we already covered that this can be used both indoors and outdoors. So the inverter is IP65. We do not recommend, for instance, installing the inverter in bedrooms or sitting areas where the active cooling fan can be a bit or can create some noise, and this can become a bit of a nuisance, especially when you want to have some silence in the room. Also, any areas that have the potential for electrostatic dust, this is not recommended for the inverter to be installed there. At the direct sun heat, this is possible. Any areas that would produce corrosive gases, maybe near chimneys from factories and stuff like that, we do not recommend installation of the inverter there, or animal houses or inside of greenhouses. So always pay very close attention to the recommendations from Fronius on where the inverter can be installed or not. And this is going to guarantee you that you're going to have very few problems when operating this inverter. In terms of the orientation, we have 4 key orientations that are permitted, as we can see here to the left. And then, so we can talk about vertical mounting on our horizontal mounting position, as well as mounting on an inclined surface. So all these other orientations shown here, about 8 of them are not allowed. Some of them also for safety reasons, because when the inverter is mounted like this, you cannot actually properly secure it to the mounting bracket. As I mentioned in the beginning, we also have the possibility to do floor mounting with the Fronius Tauro. So as we can see in this photo, we have provided some floor mounting racks, and this would allow you to directly mount the Tauros on the floor without any screwing. But then we do recommend, as you can see here, the mounting racks are actually a bit slanted. And then the perforations or the slots on the mounting rack itself would allow any water that would be running on this surface not to be blocked by the inverter, and therefore flooding issues are totally avoided by these floor racks. In terms of clearances that are recommended when you're installing the Fronius Tauro, we have also these recommendations that you need to pay attention to. So first of all, the mounting of the inverter is going to be done using this lightweight wall bracket. And then the clearances, especially for active cooling, if you do have 1 or 2 inverters, you have to pay attention to the clearances that you are leaving to the next object. So from the top of the inverter, we do recommend minimum 50 centimeters. And then from the size of the inverter, also a minimum of 50 centimeters. And that would also allow you within that distance or spacing of 50 centimeters to install a secondary or a second inverter if you have a system that is going to be using multiple multiple inverters in this case. So then at this point, I would like to hand over to Mo to be able to continue with the next part of the presentation. So Mo, if you can join us from here.
Thank you, David. Okay, so move on to the next section of today's webinar. We're going to have a look at the design options for the Fronius Tauro. So firstly, whenever you are planning a project with a Fronius Tauro, there is multiple ways that you as a EPC company or installer can actually save costs. The first one being is the CAPEX, which is the capital expenditure. The second one being the OPEX, which is the operational expenditure. And the third very important point as well is the yield. Obviously, if you install an inverter that operates better at higher temperatures, for example, you will ensure that your installation has a greater yield over a certain period of time. And as you all know, a greater yield basically leads to a quicker payback period. When it comes to CAPEX, as you will see in the next few slides, with the Fronius Tauro, by choosing a specific version of a Tauro, you can basically not need, for example, AC combiners, DC combiners, fuses, etc. So again, you can really customize your Tauro for your project in order to cut down on any CAPEX, any other CAPEX expenditures. Again, with the OPEX expenditure as well, with the Tauro and its service concept, if something does have to go wrong with the Tauro, you can always do servicing on site. So again, that is a very big point for the Tauro, and not many other manufacturers do offer that capability of offering you on-site servicing for your commercial inverter range. Moving to the next slide. So what is the cost percentage in a commercial system of a PV inverter? So generally in a commercial system, a PV inverter only costs about 9% of the CAPEX cost. So remember, your CAPEX cost is your initial cost in order to build this PV system. Okay, so here you can see a PV inverter is a tiny amount in terms of the overall system cost at about 9%. 33% is your balance and system costs, and your balance and system costs can be anything from AC combiner boxes, SPDs, fuses, DC cables, AC cables, mounting racks, and so on. 14% is about the labor, cost of labor. And the biggest chunk, 44%, is actually your PV modules. So what I always say to installers and EPCs is that a PV inverter is the most important part of a PV system. Okay, because the PV inverter basically converts your DC to AC. And hence you should not compromise on your PV inverter. Okay, you could perhaps compromise on these other parts of the pie, but my recommendation is go for a good quality inverter brand like Fronius. And as you can see, it's less than 10% of the overall cost of each system. Having a look at the next section, which is talking about the balance of system costs. So as I said earlier on, with a Fronius Tauro, we really try to assist you on basically cutting down costs on other sections of your project. For example, cutting down the costs on the balance of systems. So as you saw in the previous slide, the balance of systems was about 33%. But if we zoom into that 33%, this is how the balance of system costs are actually broken up into. So 41% of the balance of system costs is your AC connections, okay? About 20% is your DC and AC components, which can be your box, your combiner boxes, your cabling. Your cable trays is about 8%, and all your substructures, such as your PV module mounting structures, etc., accounts for about 31%. A Fronius Tauro will really target this area, so this 20% of your pie chart over here, okay? And that is your DC and AC components. Okay, so as you'll see with Fronius Tauro, we can target the DC and AC combiner boxes, and we can also target your DC and AC cabling in order to reduce that 20% of your balance of system costs. So how do we do this? Firstly, well, we have two options for your DC connection. We've got the Fronius Tauro D, or we've got the Fronius Tauro P. Okay, D stands for direct and P stands for pre-combined. So having a look at the direct, with the Fronius Tauro direct, the string fuses are integrated, okay, in the inverter itself. So what is the advantage of having your string fuses integrated in your inverter? There's no need to have string fuses in a DC combiner box, which could, for example, in a DC protection box, which could, for example, make sure that you don't have to use a DC protection box because you have fuses integrated in the inverter. In terms of the number of strings, with the direct version, it is integrated with MC4 plugs. So with the Tauro Eco 50 kilowatt inverter, you can connect up to 14 strings directly to the inverter itself. And as you can see, the inverter comes integrated with MC4. So again, when it comes to making the installation on site, it's fairly quick and easy. Okay, you don't have to do any crimping or anything to that extent. When it comes to the Tauro Eco 100 kilowatts inverter, you can connect up to 22 strings of 1000 volts DC each. When it comes to the Fronius Tauro, the P version, or the pre-combined version, with this version over here, your cable connection to your DC side is between 25 millimeters squared up to 95 millimeters squared, and we have integrated V-clamps. So the advantage of having V-clamps on the DC side with the P version is that you no longer have to do cable locks on your DC side. So again, with V-clamps, your DC connections are again much more easier, especially when you're using your DC combiner boxes. Okay, so in this first version, the D version, there's no need to use a DC combiner box. In your P version, you will use a DC combiner box. And again, with the P version, there's no fuses integrated. So obviously you will have to have a DC protection box with all your string fuses in line with your strings, okay? And with the D version, there's no need for that DC protection box because as I'm showing you over here, your string fuses are integrated. Moving on to the AC data chaining, this is now the second method that we sort of target the AC side of the system in order to cut down on the BOS costs. And with the AC data chaining, basically what it is, it's connecting multiple Fronius inverters on the AC side to each other in order to cut down on the amount of AC cables you use and also to cut down on the amount of AC combiner boxes you use. So this is a unique system design with the AC-DC chaining, and this can work up to 200 kilowatts per subsystem, okay? And this translates to 200 kilowatt Tauros or 450 kilowatt Tauros. So in this example over here, I've got 450 kilowatt Tauros, okay? The main advantage of this is that you're going to use less AC cables, okay? Less components are necessary. The reason for this is that no AC combiner and you just need one AC plus connector. Okay, so I've got a little picture over here, a screenshot of a picture, and this is an actual Tauro installation. And here we can see 200 kilowatt Tauros connected to each other on the AC side. Okay, so you can see what's happening over here. This inverter is sending all its AC output power to this inverter, okay? This inverter collects that AC power and then combines it with its own AC power and then sends it along to the nearest transformer, for example. I just want to show you some comparative examples when using the AC-DC chaining. In the first example, you can do an installation without an AC combiner. Okay, so here you've got two Tauro inverters, and here you've got your main distribution frame, where you'll most likely find your AC transformer. In this example, your Tauros are directly connected to your AC distribution frame. Okay. It so happens that Fronius Tauro 1 has got a 100-meter AC cable and Fronius Tauro 2, because it's a bit closer, has a 50 meter AC cable. With both of these Tauros, you are limited on the AC side to a cable cross section of 240 millimeters squared. Okay. And in this particular example, you're going to have two AC disconnectors at the transformer. Okay, so you're going to have one AC disconnector for Tauro 1 and one AC disconnector for Tauro 2. So in this example, you're going to be paying for two AC disconnectors, and you're also going to be paying for 100 meter, 240 millimeter squared cable, and a 50 meter, 240 millimeter squared cable. The second example is an installation with an AC combiner being used. Okay, okay, remember this is a third-party AC combiner. So Fronius, we do not produce AC combiners anymore. Okay, so you'll have to make your own AC combiner, or you need to purchase an AC combiner box from a third-party vendor. In this example, we got two Fronius Tauros, Tauro 1, Tauro 2, and then we've got our main distribution frame. Okay, we placed the AC combiner box closer to Tauro 2, but we still have a 3 meter cable between that combiner box and Tauro 2. We still got a 50 meter cable between Tauro 1 and the combiner box, and we also got another 50 meter cable from the combiner box to the main distribution frame. In this example, okay, I'm using 120 millimeters squared combiner. Okay, the reason is that cable is 120 millimeters squared and that cable is 120 millimeters squared. The output cable obviously will be 240 millimeters squared to the transformer. In this particular example, we only have one AC disconnector, and that's located at the transformer. However, this AC disconnector is rated for 320 amps, okay, compared to this one, which was 160 amps because we're using two. The third example, I'm using AC-DC chaining. So I've got Tauro 1, Tauro 2. I've got a 50 meter cable between Tauro 1 and Tauro 2, and a 50 meter cable between Tauro 2 and your distribution frame. With this example, it's a AC-DC chain option, okay? So whenever you're going to use an AC-DC chain option, you've got to make sure that both this cable and that cable is rated for these two systems put together. Okay, so what do I mean by that? So if you look at the previous two examples over here, in this example, we had 120 millimeter squared cable running from there to there, and 120 millimeter squared cable running from there to there. In this example, 120 millimeter squared, 120 millimeter squared, and 240 millimeter squared. But in this example, we got to size it for the total output power of both inverters. So similar to that cable over there. So that's going to be a 240 millimeter squared, and that's going to be a 240 millimeter squared. Okay, so you have to size each cable to be equal to each other, but it has to carry the total current for both these systems. Okay, hence 240 millimeters squared. In this example, you'll still have one AC disconnector at the transformer. So if you compare the three together, you can see with the AC-DC chaining, you're really making the greatest saving possible. Because with the AC-DC chaining, there's no need for a combiner. So there's no need for that AC combiner, okay? And now you're only running 50 meters cabling, compared to here, we had an extra 3 meter cabling as well. And also compared to the first example, there's now no longer a need for 100 meter cable. Okay, we've cut that into half by using a 50 meter cable. Okay, so with AC-DC chaining, it's always more profitable at the total cost level, and it is the best option to save on AC cable lengths. And it is a very interesting option when return of investment is most important. And this again will lead to lower investment costs. Okay, moving on to the next section, which is your design flexibility. So when looking at the layout overview for your DC side, as I said earlier, there is a D or P version. I'm going to focus on the D version for now, and I'm giving you 3 case scenarios. The first case scenario, we've got a PV field, and all those modules are connected to one Tauro inverter. And that Tauro inverter has a 240 millimeter squared cable. Okay, remember, 240 millimeter squared is the maximum cable cross section you can connect on the AC side to a Fronius Tauro. And that cable is connected to your main distribution frame. Okay. The second example, I've got 2 PV fields. PV field 1 is connected to Tauro 1, and PV field 2, which is maybe pointed in another direction, is connected to Tauro 2. Okay. Between these 2 Tauro inverters, I've got DC chaining, AC-DC chaining. Okay. And I'm now only running one AC cable from the second Tauro to the main distribution frame. And this AC cable is rated for, well, it's 240 millimeters squared in terms of cable cross section, and it's only running for about a distance of 60 meters. The third example, I've got one PV field, which is connected to one Tauro inverter. Okay, but with this example, my main distribution frame is really far away. So it's over 230 meters away. And as you know, the further we go in terms of meters, especially with the AC cable, because remember with the AC cable, your current is high and your voltage is low. So your losses are very high. And how do we overcome those losses? The first option is that we can use thicker cabling, okay? Because remember, the thicker your AC cable is, the less resistance there is to the flow of current, so the less losses there is. So if you choose to use the AC-DC chain option, so remember the AC-DC chain option has 10 outputs on your AC connection, okay? It's got 5 for your first AC connection and 5 for your second AC connection, okay? So in this example, I'm using the AC-DC chain option in order to cut down on my losses due to the wide distance from the inverter to the transformer. Okay, so here I'm using 2 by 240 millimeters squared AC cables, and I'm splitting the current between them, okay? And hence I will have less losses over a longer distance. So again, this is why I said with the Tauro, you can really use it to whatever you want that Tauro to do for you, and whatever you want the savings to be, whether it's on the DC side or AC side. If you're looking at the P version of the Tauro, in this example here, I've got my PV field, okay? But over here, I've got DC string combiner boxes. So I'm using DC combiner boxes on the DC side, and over here, I'm then running 2 by 95 millimeter squared cabling to my P version Tauro, which is a pre-combined Tauro. And that Tauro, as you can see, can be placed as close as possible to your transformer. With the second example over here, I have a really far distance to cover. So from my PV field to my transformer, it's about 460 meters compared to the previous example where it was 230 meters. So in this example, I can choose to place the Tauro in the middle in terms of distance-wise, okay? And here I can use a DC string combiner box with a pre-combined Tauro. Okay, so I have 2 by 95 millimeters square cabling. Obviously, one for your positive, one for your negative. That goes to your Tauro, okay? And now with this Tauro, I've ordered a AC-DC chain option. Okay, so here I can have 2 outputs on the AC side, so 2 separate AC cables, okay, to cut down on AC losses to the main distribution frame. So what are the advantages of the Tauro Ps? So firstly, your DC cables are cheaper than your AC cables. And remember, generally, DC cables are about 4 times cheaper than AC cables. Okay, so if you can save on your AC cables by reducing the length of your AC cable by using AC chaining, I would suggest you do go ahead and do that, because as you can see, DC cables are much cheaper than AC cables. There are also much less losses due to high DC voltages with the Tauro P. And again, this is because with a DC cable, so with your DC cables from your solar panels, they're generally in the range of between 700 to 800 volts DC, okay? That's a very high voltage, okay, compared to what the voltage would be on the AC side. Okay, remember your voltage on your AC side is about 230 volts line to neutral, or 400 volts line to line, for example. Okay, so as you can see, 800 volts is almost double that on the DC side. There's also a greater distance possible, okay, with the P version Tauro. And again, we can take aluminium or copper cable cross sections with a maximum of 95 millimeters squared. Moving on to the next section, which is your layout examples. So this is the first example where you've got multiple PV fields, and each PV field is about 125 kilowatt peak. And in this particular example, we're using 100 kilowatt Tauro inverters. So remember, the Tauro inverter has 1 tracker. But here you can see what I'm doing with 1 tracker. I have 8 inverters, so technically I have 8 trackers, okay? And I'm using these inverters to connect these inverters to PV fields which are located in different areas on my installation. And maybe they're pointing in different directions. Okay. So this is a 1 megawatt installation, okay, on the DC side, and it's an 800 kilowatt installation on the AC side. The reason for that is that you can oversize the Tauro inverter by 150%. But in this case, I'm just oversizing it by 125% on the DC side. What is the advantages of going with this sort of a setup? Okay, you don't need any additional DC combiner boxes. The reason for that is that your PV panels are connected directly to the Tauro inverter itself. The second reason is that it's easy planning. It's a standard design. It comes integrated. So these Tauro inverters come with the option for integrated string fuses and also come with the option for integrated SPDs on the DC and AC side. The third advantage is that there will be the ability to do string monitoring. So if you purchase a direct Tauro inverter, we will be releasing a firmware update in the middle of next year. And that firmware update will enable you to do string monitoring. So if you got this Tauro inverter over here, which is connected to 22 springs, you can literally monitor the voltage and current on each string, which, as you can imagine, as an EPC company, that will do a lot of wonders for you, because you can really pinpoint if you have any issues on any string without having to go to site. The second sort of example of this sort of installation, a different way to do it. Here again, we've got the same amount of DC, so 1 megawatt. Okay, we've got the same amount of inverters, 8 inverters. But what I'm trying to do here is I'm trying to cut down on my AC cable costs. And how do I do that? I order the DC chain option on the Tauro. Okay, so this is the Tauro D, so Tauro direct version with the AC-DC chain. And here we can see how we connect the AC between two Tauro's inverters together. And we then run the AC from the first or last Tauro back to your main distribution frame. The advantages here is that we have no additional DC combiner boxes. String monitoring is still possible, but here we have shorter AC cables and less AC cables, which again leads to lower cable costs. The third example, so here we have a total of, you can say 16 Fronius inverters. Okay, but over here what we're doing is that we're sort of going to use combiner boxes. Okay, so we're using your DC combiner boxes connected to your pre-combined Tauros. Okay, and here we can see how we're kind of saving on our AC cable costs. Okay, because we're positioning all these Tauro inverters in one room, perhaps, and that room is really close to the main distribution. Okay, the next possible design is that, let's say you have an installation for a client, and this client has different buildings. Okay, so maybe he's got a car park, maybe he's got a little factory, and maybe he's got a little office building. Okay, so it's 3 different areas where your PV modules are going to be located. So the first area is going to be on the carports, second is going to be on the little factory, and third will be on his office. Okay, so in this case, we can choose to install the Tauro directly on each of those sites. Okay, so the first Tauro, which happens to be the furthest from your main distribution frame, will be on the next to the car park. Okay, so maybe this Tauro will be mounted on your car park frame or something to that effect. Okay, and here we're going to make use of the AC-DC chain option. Okay, and here we're going to run 2 AC cables to your main distribution frame in order to counter the losses due to the long distance on the AC side. Then over here we've got your 2 direct Tauros. Okay. For example, this Tauro is connected to these PV modules which are pointing in a certain direction, and the second Tauro is connected to PV modules which are pointing in another direction. Okay, and again we're making use of AC-DC chaining, and that again is connected to your main distribution frame. And the office building over here, all the modules are pointing in one direction. We connect it to one Tauro, and that Tauro is then connected to your main distribution frame. Okay, moving on to the next section, which is your system design with the Fronius software tools. So whenever you're planning a project with the Fronius Tauro, we sort of have 3 platforms that you can use for Fronius to assist you. The first one is the Fronius Solar Configurator. With the Fronius Solar Configurator, it's free to use. And what's really nice about the configurator is that the configurator is tailor-made to assist you in planning your strings with any Fronius inverter, such as a Tauro. That's what it is in a nutshell. The second program that we do have available is called your Fronius Solar.CREATOR. Okay, and in order to access the Fronius Solar.CREATOR, you just have to go to creator.fronius.com. Okay, and over there you can basically sort of plan and design your system using a Fronius inverter. The third application we have available is called the Fronius Tauro configurator. And with the Fronius Tauro configurator, you can use the Tauro configurator in order to choose which Tauro you want to order for your project. Okay, so I'm just going to show you a quick demo of the Tauro configurator and how it works. Okay, so all you have to do is go to tauroconfigurator.fronius.com. Just put that in your web browser. And if you're ever planning a system with a Tauro, I always recommend that you should have a look at this tool in order to see what sort of options are available for your Tauro inverter. So you just click on Start. Okay, the first question will be, what is the system design? Do you have a centralized design or a decentralized design? Okay, so do you have a pre-combined or a direct version that you require? Okay, let's say for this example, we want to go for the direct version, so the decentralized version. Next question will be, what type of inverter are you going to use for the system? So we have 4 different types of Tauros. And the first one is a Tauro 50 kilowatts with 3 MPPT trackers. The second one is the Fronius Tauro Eco 50 kilowatt with 1 MPPT tracker. The third one is the Fronius Tauro Eco 99 kilowatt with 1 MPPT tracker. And the fourth one is the Fronius Tauro 100 kilowatt with 1 MPPT tracker. Let's say for this example, I want to use the 100 kilowatt inverter. Select that one. The next question or the next option is, what fuses do I want integrated in this inverter? So these are your DC fuses. So do you want 15 amp DC fuse or do you want a 20 amp DC fuse? Okay, in this example, I'm going to choose a 20 amp DC fuse per string. Your next option will be, what type of SPD do you want? So with the Fronius Tauro, we can provide you an SPD for both the DC and the AC side. Okay, and we have an option of the SPD type 1+2. So remember, with your type 1+2 SPD, that will protect against lightning and overvoltage on the DC and AC side. Okay, with your type 2 will only really protect against overvoltages. So if this installation is in an area where there's a lot of lightning, my recommendation is to always order the inverter with type 1+2. But if you install the inverter in an area where there's hardly any lightning, save costs and go for the type 2. Okay, so for this example, let's use the type 1+2. We select that. The next option we have is the sort of AC connection that you want to order the inverter with. There's 3 types of AC connections. As I talked about quite a bit in today's webinar, is the AC-DC chaining option. And here you can really see how this option looks. So you've got your 5 inputs. So L1, L2, L3, neutral and earth. L1, L2, L3, neutral and earth. Okay, so 5 inputs for in and 5 inputs for out. The second option is your single core option. And with the single core option, you can take cables of between 10 to 28 millimeters. With the multi-core, you can take a cable in total size of about 63 millimeters. Okay, and that's how the multi-core connection looks. And yeah, that's how your single core looks. Let's say for this particular example, I want to use the AC-DC chain option. So we select that. And because I'm using the AC-DC chain option, I can't add the AC disconnect to this inverter. Okay, but if I selected the single core or multi-core option, I would have the added optionality of actually ordering this inverter with the AC disconnector. Okay, so we click on next, and you then have your order. And what you can do is you then send this order to Fronius, and we can, get back to you with a quote. Okay, moving on. I just want to run through some references that we have done with the Tauro already. Okay, the first reference I want to show you is a 1.3 megawatt installation. This was done in Austria. And why I want to show you this reference is that you can see there's two power plants running in parallel. So we've got a hydroelectric power plant over here, and here we've got a solar PV power plant. Okay. In this system, there was 12 Fronius Tauro Eco 100 kilowatt units with a Fronius smart meter. These inverters were the decentralized inverters, so the D version. And as you can see with the D version, in this particular example, we mounted this Tauro inverter directly underneath the PV modules. So we actually used the PV module structure to actually hold up the Tauro as well. The reason you can do this is because the Tauro is IP65 rated. Okay, so you can install it indoors or outdoors. It can take, high ambient temperatures. That's not a problem. And yeah, it can also take direct sunlight as well. The second example I want to show you is a 1 megawatt field installation in Greece. Okay, so in this field installation, they use different types of Fronius Tauro inverters. They use the 100 kilowatts and the 50 kilowatts. Okay. In this particular example, they use the DC chain option on some of the inverters, and some of the inverters they chose not to go for the AC-DC chain option. Okay, so here you can see in the first picture, we've got AC-DC chaining happening between two inverters. In this third inverter, there's no AC-DC chaining happening. Okay, so for further information, you're more than welcome to go to our Fronius website. You can also check out our YouTube channel. So search for the Fronius Sub-Saharan Africa playlist, and that's where we have uploaded all our webinars for the Sub-Saharan African region. I am showing you a few contact numbers on your screen. So if you are interested in contacting a certain Fronius department, you're more than welcome to do so. But from my side, I'd like to thank you for joining today's webinar. We will be keeping the Q&A session open for another 5 minutes. So any questions that you have, please do post it in the chat functionality. Webinar. From my side, goodbye, and hopefully we'll see you in another webinar. Goodbye.